Hello again, Cougar Academy, Algebra 2A, and welcome to lesson 2.2. And this time, we are looking at just functions in general. So essential question, what is a linear function? Okay. And also, how do you evaluate function notation? How do you evaluate function notation? Alrighty. Our first definition is the notation and evaluating functions. So notation of our new functions here. We get a little fancy with our mathematics. Basically, we're just taking the word function and putting a little x after it. That is it. That just means, essentially, what it means is it's a fancy way of saying y. Now remember, a function is special in that all the x's have one y value. Okay, so it just means that all the x's in this function have one y value. Okay, so you might see f of x, you might see g of x, you might see q of x, r of x, t of x. You might actually also see it doesn't have to be x, it could be h of t, or w of p. Okay, basically the x is your input. Okay, that's your input values, or the t and the p, and what's on the outside is what the relation is. Okay, that's it there. Now, evaluating functions. When you're evaluating them, say you have a function. So we'll basically do some examples here. Just know that when you're evaluating, you are substituting given values for x. Okay, you're just substituting values in for x, and there may be more than one spot. Okay, next up, so that's notation. Evaluating, we're just going to look at a chart of a whole bunch of examples, and also linear functions. Linear functions are functions that represent a line. Okay, pretty straightforward. Now it could be a horizontal line, it could be an oblique line increasing, it could be a decreasing oblique line. There are functions that are nonlinear, so versus nonlinear. And we'll work with those later. Those are more of your parabolas. Okay. And also things like we have sine waves that will be coming up. That's a cubic function and other things. So there are nonlinear functions and linear functions. Right now, we are going to be identifying simple linear functions. Another example of nonlinear, sorry. Okay, so this is like an x squared. This is x to the third. This next one is going to be absolute value of x. Okay, that is non-linear because it looks like a v. If we have something that is, say, x to a negative power, okay, that is non-linear. Another example of non-linear is the square root of x. So it does seem like there's quite a few here. And if we have a fraction, so 1 over x. Those are all examples of non-linear. So take a moment to write those down. If you see any of these cases, x to a power that's other than 1, it is non-linear. The only ones that are linear are functions that have just x to the first power, okay, or are constants. Okay, so let's just look at some examples. All right, so our first relation that we're given, I'm asking you, is it linear or not? So it's just x to the first power. All right, so yes, it is linear. And that's because it's just x to the first, okay? If you were to graph this, so if you have your graphing calculators, great. And you go under y equals, clear anything else out in there. We'll get some practice using this. Remember, f of x is really just fancy for y. And we type in 3x plus 4. We get a nice graph of an oblique line, and that tells us it's linear, okay? The evaluating part, f of negative 2. Here's what students like to do. They like to put it in for x here, and then divide. But really, f of negative 2, all it's asking you is put in negative 2 where that x is. So it's just 3 times negative 2. Let's put that in blue. And then plus 4. Okay, you just need to operate on the right-hand side. 3 times negative 2 is negative 6. And negative 6 plus 4 is 2. So that's the evaluated negative 2, sorry. That is the evaluated function at negative 2. You don't need to divide by negative 2. Okay, it's just negative 2 right here. All right, so you don't need to divide again. Just ignore the left and go from there. Alrighty, another relation, g of x, 1/3 x plus 2. Now I know I mentioned for nonlinear, if you see a fraction, it might be nonlinear. But our fraction here is not involved with the x, it's out front. So this one is still linear. Okay. It's a linear function. And again, when in doubt, graph it out. How about that? 1/3 x plus 2. And we go to the graph, and there's the table. But anyway, the graph here, we see it's an oblique line. It's just a little less steep. And again, it's linear because it's x to the first. The fraction out front doesn't throw it off. G6, like bingo. Here, it is 1/3 times 6 plus 2. All right, so 1/3 times 6, well, that is 2 plus 2. Evaluating means we have 4. So here's where our order of operations stuff comes into play. G of 6 is 4. H of x, negative. Same idea as the last one. The x is to the first power. The negative out front means it's still a function. And again, if you just need the visual representation, negative x minus 3, go to the graph, and you see it's a line. So it's still linear. Let's evaluate. So negative of negative 2. Negatives can be tricky. I like to always plug in things into parentheses because that helps me to not forget negatives. Negative times a negative is a positive. So we have -1 as our answer. All right, now let's continue on. Here's our first nonlinear. And no, not just because it's about time for that, but because it has the squared power. Okay, so it does not have a power of 1. So because of x squared, that is y. So it's nonlinear. If you were to graph this, 3x squared plus 2, okay, it's pretty evident that when you look at it, that does not look like a line, okay? A 6-year-old can answer that. Is that a straight line? No, it's a curve, okay? So we can still evaluate. We will still evaluate. Just have to be careful and know that it's nonlinear. When we evaluate, it's 3, quantity -2, actually -3, sorry, we're plugging this -3 in. And that's what's being squared. and then we're adding 2. Now, calculators, you're certainly able to use them. Be careful with negatives. Anytime you square a negative, it'll become positive. So if you're wondering how we get 29, well, that's because this is 3 times negative 3 squared is 9 plus 2, which is 27 plus 2, which is 29. So just be careful. You should still evaluate nonlinear functions. It's still a function. It's just nonlinear. All right, the next nonlinear example is 1 over 3x. Again, this time now, x is in the denominator of a fraction. So x is in a fraction's denominator. And notice the difference between these two, between our second example and this one. Here, the x is outside the fraction. Here it's inside. So that's the little difference. When in doubt, graph it out. So you're like, what's the difference, Mr. D? Well, if you were to look at it and graph it, you're going to be like, what in the world? Those two little things there, boop, 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 boop. Those are the parts of the graph, okay? So not a linear function. We will still evaluate it. It is 1 over 3 times negative 4, which is a fraction, just 1 over negative 12. Doesn't matter if you have the negative above or below. You can leave it as a fraction. Alrighty, another example here. What do you guys think? Is it a linear or nonlinear? You're like, it's nonlinear because I mentioned square roots are nonlinear. So, nonlinear. We're still going to evaluate, and the reason why, that's square root of x. Nonlinear, so t of 4. So square root of 4 times 4 plus 2. We're going to do this part first. So it's square root of 16 plus 2. If you don't know your square roots, that's all right for now, but you should be able to handle square root of 16. It's 4 plus 2, which is 6. Boom, 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 boom. Alrighty. Z of x. X to the negative 2. Once again, a nonlinear. Due to the negative exponent. All right, this one could be a little trickier. We will use our calculator. So we're going to do z of 2, which is 2 to the negative second power plus 3. Later in this course, we will look at negative exponents. For right now, you can type in 2 caret negative 2. That will get you to the negative 2 power and plus 3. You'll get a decimal. You can also rewrite it as a fraction. That's 13/4 from there. Okay, I'll accept either answer. I typically like fractions if you can. Last one. Here is our little trick. Okay, first off, is it linear or nonlinear? All right, so we look at it, we see a square root. Now, don't just jump to conclusions because of the square root. The x itself is outside of the square root. Okay, so this particular problem is linear. Okay, and again, you can always type it in and try. So second square root 16 outside the square root is plus x. And really all of this equation is it's the equation 4 plus x, because square root of 16 is just 4. Okay, so the main idea is don't just assume that it's nonlinear because you see a square root. W at 5 is a square root of 16, okay, plus 5, replacing x with 5, and that's just 4 plus 5, which is 9, okay? So be careful of those little things. If you were to see, again, an absolute value of x, that would be nonlinear. So that's an example we didn't do. Anything like x to the third. Again, when in doubt, graph it out. That is your slogan for the day. All right, guys. Lesson 2.2. Good stuff. Linear, nonlinear. Practice those problems.